In this podcast, we're gonna look at matching graphs. Look for the obvious first. Obvious things are, is it growth versus decay? What's the horizontal asymptote? Does it have a negative starting value? Right? If it's reflected across the x-axis, it has a negative starting value. If you get to those three, you've done those three and you can't figure it out, they're too close, then substitute values for x and solve for y and see which ones match. But this one you can do by inspection, and this one requires work. So do the ones that you can do by inspection first, and then do the ones that you need to do work for. Let's identify growth versus decay. So I'll just have you call it out. So we're going to look at the graphs, and let's look at the equations, and then we'll look at the graphs. So how about 19, y equals 0.25 to the x, growth or decay? Decay. How about negative 3x minus 1 plus 3? No one's answering on this one. It is growth. So let's just review that it's decay if your base is between 0 and 1. And it's growth if your base is greater than 1. Here our base is 0.25, that's between 0 and 1. Here our base is 3, that's more than 1. Right? So the negative is not part of the base, so that would be growth. How about negative 1/3 x minus 1 plus 3, growth or decay? That is decay. And our base here is 1/3. How about y equals 1/2 x at 1/2 to the x minus 1 power? Decay. And our base here is 1/2. How about y equals 0.25 to the x? Decay. And our base is 0.25. And then how about y equals 0.5 to the x? That one is also decay, as our base is 0.5, same as 1/2. All right, let's look at our graphs here. Is it growth or decay? How about A, growth or decay? It's showing decay, right? So decay on a graph, it goes, it decreases as x increases. How about B, growth or decay? Decay. How about C? Decay. It's in the negative direction, but it's going to the axis. It's decreasing in the negative direction. How about D here, growth or decay? Decay. No, that one's decay. Because it's decreasing in the negative direction. The next one is growth.
That one already has a match, right?
Yeah. And then the last one here? Decay. So when you're negative, so here notice our y values are increasing in the negative direction. It's moving away from the asymptote. So another way to think of it is graph moves away from the asymptote. So I think we know which one it is. But by the way, what was the horizontal asymptote here that it's moving away from? Y equals 3. All right, so right here, good idea to draw that asymptote in. So add the things in your notes that I put up here. All right, so y equals 3, horizontal asymptote. No trouble figuring out which one is this one. So where should E go? 20 is E. All right, so just by looking at growth and decay, we found one of our matches. Let's identify the horizontal asymptotes for each of the graphs now. So that was the easiest thing, is growth and decay. All right, so horizontal asymptote. What's the horizontal asymptote for 19? 0. Y equals 0. How about, we already did 20. How about 21? How about for 22? Yep. Number 23. And 24. And -1. So it's always that value added in. Right? If nothing's added in, it's 0. So now we could figure out two others, because there was two graphs that had a horizontal asymptote of 3, but we already figured out one of those. Let's label the horizontal asymptotes on the graph now. How about A? What's the horizontal asymptote? -1. So here, our horizontal asymptote is y equals -1. We can draw it in right there. And that means there was only one graph that had a horizontal asymptote, one equation that had a horizontal asymptote of -1. It was 24. So 24 has got to be A. Horizontal asymptote for B, 0. Horizontal asymptote for C, 0. Horizontal asymptote for D. What was it? 3. So that's right here, y equals 3. We'll draw that in. All right, and there was only one graph. Well, if there was two graphs that had a horizontal asymptote of 3, but we've already figured out one, because one was the only one that was growth. That was E, was growth. So the only other graph that's got a horizontal asymptote of 3 is 21. So 21 is D. And then what's the horizontal asymptote for F? 0. And we'll draw that in. All right, so we're half done just by looking at whether it was growth or decay and what the horizontal asymptote is. The next easiest thing is a negative starting value. All right, so we won't worry about 20, 21, and 24. How about 19, positive or negative starting value? Positive. Right? Our A here is 1. How about 22? Positive, A is 1. So notice there's nothing in front of that base. Its starting value is 1. How about 23? Negative. Starting value is -1. All right, let's identify the graphs that haven't already been used. So we won't look at A, D, and well, we could look at them. We'll write it in anyway, even though we've already identified it. Does A have a positive or a negative starting value? Positive. Whatever it is, I just put +1. I don't know what it is. It looks like it's 1, and actually if we look back at the graph, we've already identified it is 1. Right? So I can put +1. That was a positive. All right, and then how about B, positive or negative? That's positive. And how about C? That's negative. And D, negative. And we've used that one, right? So we know that one's -1. And then E, negative. And we've used that one already. We know it's -1 technically, not -3. 3 is the base. And then how about F? Positive. All right, so all we have to do is look, is it above, is it reflected over the x-axis or not? There's only one left that's negative. So what's our next match? C and 23, yep. All right, so now we're down to 2 graphs. We did all the obvious, easy things. We got to figure out the next one. So let's look at the points on there and see. Let's substitute the x value and see if which y value it gives us. All right, so here, notice the 2 that are left are, I'll mark them in blue. We did not use. We used A, so A is out. I'm going to just cross these out. A is gone. B has not been used. Right? B has not been used. C is used. D has been used. E has been used. And F has not been used. All right? So we have 0, 0, and we have 1, -2. All right, so and here we have -1, 4, and 0, 1. So notice if we've got y values for 0 and 1. Let's try plugging in, and we had 0 for both of them. Let's try plugging in 0 into both equations and see what it gives us. All right, so if we plug in 0 into B, right? Excuse me, into 19, who's left over here? So we have that one done, that one done, that one done. 19 and 22 are the only ones left, so these two are left. If we plug in 0 into 19, we'd get 0, or I should say y equals, right, so 0.25 to the 0 would give us 1. And if we do that for 22, plug in 0, 1/2 to the 0 minus 1. That's the same as 1/2 to the negative 1 power. What's 1/2 to the negative 1? 2. All right, so this one has 0, 1 on it. Uh-oh. 0, 1 goes with this one, but this one has 0, 0. Did I leave something off that equation that I wrote all over? Did I plug into the wrong one? Oh, I'm looking at the wrong one. I'm looking at A, sorry. A's been crossed off. It's B I need to look at. Good. So I don't care about 0, 0. 0, 2 and 0, 1. So now we can see 0, 2 is 22, right? Because that one has 0, 2 in it. And if we plug in 0 into 22, we get 2. So 22 was B. And the last one, 19, this one was F. Right? So I know it's a little crammed in here, but hopefully you could follow along with the graphs. Any questions on this one? All right, so let's identify the characteristics here for this graph. We know its equation, f of x equals 2 to the x. All right? Sometimes the answer will be none. I mean, that is possible. How about x-intercept? What's the x-intercept? Anybody at the orange table? None. Right? It's not going to cross the x-axis, so it doesn't have an x-intercept. How about the y-intercept? Orange 4. It is 1 right there. So 0, 1. How about the asymptote? In this case, it only has a horizontal asymptote. Anybody at the green table?
Horizontal asymptote at 0.
Yep, y equals 0. And these are all in your notes. How about the domain? Red 4.
Oh, that's me. Is it? Yeah. Okay.
Yeah.
Domain?
Yeah.
All the numbers.
Yep. How about the range? Blue 4. No, blue 4. Yellow 4. Yep. 0 to infinity. And how about intervals of increase, decrease? Green, no green 1. No purple 4. Blue 2. So as we look from left to right, is our graph increasing or decreasing?
It's increasing.
Is it decreasing anywhere?
Going from left to this.
No, we always read from left to right.
And nose.
Then no, right. So there's no decrease. There's not a trick question, no decrease. So if it's increasing everywhere, what's that? That was Emily who answered that question. So if it's increasing everywhere, that means that our interval of increase is negative infinity to infinity, right? Because we read graphs left to right. Yeah. So regraphs left to right. Any questions on this one? Let's do another one. So these are some basic features you should be able to identify if I give you the graph of an equation. Okay. So we're looking at the red graph, h of x, right? So h of x equals 1/4 x plus to the x plus 2, right? And we have our base graph. This one's the base graph here. And then this is the translation. We're only going to look at the translation. X-intercept, yellow 3. No, there's none. Colleen says none. There's none. y-intercept, or x, yeah, y-intercept, no blue 5. Green 4, no, red 5. Harold, what's the y-intercept?
It's 0, 3.
Yep, right there. Asymptote, orange 1.
Or maybe 2.
2.
No, no.
Y equals 2. Domain. Anybody at the red table? Domain. Yep. That's the second question time for you. Orange 2. The range.
That's yeah. 2 to infinity.
Intervals increase, decrease. Anyone at the yellow table?
It's decreasing the entire time.
Yep. This one decreases everywhere. And yeah, that's fine. And we can say decrease negative infinity to infinity. Right. So you'll find with the exponential graphs, they either always increase or they always decrease. All right, so let's take a look at this one. Yellow, no yellow one. Anyone at the blue table, x-intercept?
No.
None. I'm going to write in a new color. Tired of writing in red. None. Y-intercept, orange 5. Yeah, right there. Horizontal asymptote, orange 5.
That's the same person.
Oh,
Unless you want to.
yeah. I'm going back the other way now. 0. Now I'm just grabbing and putting them back. All it sticks. Orange 2.
I know. All real numbers.
You're not going to like the next one then. Orange 1, range.
Reverse the whole thing. Negative infinity to 0.
That were reflected, so it's going to be negative infinity to 0. Intervals of increase, decrease. Anybody at the red table? Are you sure?
Is that not decay?
It is decay. It is decay.
Also increases everywhere.
Yeah, but it is increasing everywhere.
Oh, yeah, that's what you said.
Right? Because technically, these numbers are larger, right? So a smaller negative number is technically larger. So it is increasing everywhere, even though it's decay. So I think next one's my last one. So let's identify the following characteristics. The x-intercept. Yellow, go yellow 2, oops, I'm going the wrong direction. Anybody at the green table?
Is it like 1.5?
A little bit less. Maybe like 1.25. Yeah, something like that. We don't have an equation, so we can't plug in. If we had the equation, we could plug in 0. So it looks like it's about 1.250. So we have to estimate on that. A reasonable estimate is good. So this one, because it's been shifted, it has an x-intercept. How about the y-intercept? Green 2. Green 3.
It is 0, 2.
Yep. Asymptote, blue 3. Yeah, right up here. And actually, I should have put those in for the other ones too. Let's actually draw those in. So, not as important on the other ones on the 0, but we'll do it anyway. So here's the asymptote for this one at 0. Here's the asymptote here at 2. Here was the asymptote at 0, so we can just see it. Because they don't draw those in when you give a quiz or test and they give you a multiple choice question. They don't draw those in. Domain, orange 4.
Yes. Is it all real numbers?
It's all real numbers. How about the range, yellow 4? Yep. And intervals of increase, decrease, yellow 3. It's decreasing everywhere. So decreasing everywhere or decrease negative infinity to infinity, even though it's growth. So this one is growth. But because those numbers are getting more negative, it's been reflected that it's decreasing. So it's kind of hard to think of decrease and growth. Technically, the numbers are getting more negative. So this question's going to be, you don't have to watch the, so everyone who's not in this classroom has to watch this Nearpod. Everyone who's in this classroom can skip to this question, and it's going to be a draw. In other words, you can, with your fingers, match the graphs. I made this one a little easier than the one that I did.
Like on the computer?
Yeah, you can literally do it on the computer. Actually, not with your finger, sorry. With the mouse you can draw. Unless you have a computer you can do that with. This, however, is going to be a classwork problem that I'll give to you. This one and this one and this one. Actually, you know what? Let's have everyone who's not in this classroom do this on the computer. Let's have everyone who's in this classroom do this one for the closing. So this is the closing. And so the people that, if you're doing it on the computer, you can write it down the closing, or you can just do it on the computer. Either one is okay. But I'm ending this podcast. Bye.